Okay, here we go with our very first physics lab for the semester. Since we are on remote instruction for this week, I'm going to walk you through the instructions, the data collection, as well as the analysis. And I'll ask you to complete the remaining write-up on your own and have it prepared for submission next week. You have access to the lab documents in the course documents that were presented to you on the first day of class. So I would suggest that you have those printed out and in your hands for this assignment today. If you're printing from the master copy, this first lab is only pages number 1 through 5. You don't have to print out all 12. For this activity, make sure that you place your name at the top. Do not enter anything for score. That's where I'll be reporting your results. For lab partners, go ahead and enter none for this case. And then for instructor, you can place my name and today's date. We'll always begin every lab by rereading the instructions and note any changes to the instructions. Before our labs on Friday, I do expect you to read through the instructions at least once so that when we go over them in class, you'll be able to address any questions that you might have or ask for clarification on any of the instructions. In this case, our objective for today is to measure the displacement and time down a hill, and an opportunity for correction applies itself here. We're measuring the displacement and time needed for a cart to roll down a hill. So that's going to be a little clarification note here. We're rolling a cart down a hill, and we're going to measure the time and displacement of that object. An additional objective I should say, is to examine uniformly accelerated motion. The equipment that we need today is a Pasco dynamics track instead of vernier. We're going to be using track end stops, a blue Pasco plunger cart, a meter stick, stopwatch, wood blocks, and graph paper. There is a blank copy of graph paper that's been made available in your course documents. In case you don't have any at home, you can print some up on a sheet of paper. And for a little bit of background information, since we haven't discussed this specifically in class, we'll note that an object under the influence of a constant acceleration is said to be in a state of uniform motion. And the cart that we have and the track that it will be rolling on will meet these criterion. The acceleration of the cart that we will calculate is ultimately dependent upon the angle of inclination of the hill, and we intend to show that with our data collection today. It's implied that the greater the angle of inclination, the greater the acceleration will be on that cart. In this experiment today, the relationships between displacement, sometimes known as distance, the displacement, time, velocity, and acceleration will be explored and calculated as necessary as the dynamics cart rolls down the incline track. So we'll take some measurements based on how this cart rolls, and then we'll investigate these objects in this report today, or in this activity today. Now, as far as the experiment goes, the following steps here will explain how we're going to conduct the experiment today, and ultimately we'll get to the point where we can perform our analysis. Now, my goal with this video is to, I'll set up the experiment off camera and we'll resume in just a few moments when we're ready for data collection. But my goal is to collect the data in real time and provide you some information and instruction on how to perform your analysis as we would normally when we see each other face to face for lab. But the final write-up and the questions that must be answered, I'll ask for you to do on your own time. And in this case, those questions appear towards the end. I believe, yes, starting at number 18 to 20. These are going to be analysis or interpretation questions that I'd like for you to complete on your own. Now, when we're meeting face-to-face, recall that I said the first 2 hours of our lab are going to be required. The last hour is going to be yours to determine whether you want to stay and ask for help and clarification or use that time to work or move on to another project in the building. These are the style of questions that I think would be perfect for you to work on during that last hour. That way I'm available or other students are available to bounce some ideas off of as you work. Now, as far as the experiment goes, we're going to first set up the track and the cart to make sure that it's ready to go. We're going to place the feet of the dynamics track on the far ends of the track and secure them in place. We'll level the track and make sure that the cart will not roll on its own. And then we'll put an end stop at the end of the track towards the end of the track at the 0 centimeter mark. We will use a single wooden block underneath the feet on one end of the track. This will establish the incline. So I'll be able to do these 4 setup steps off camera, and after we're done with this introduction, the video will resume when we're at a point to collect data. As far as collecting the data goes, we're going to place the cart towards the high end of the track and make sure that it's at least 80 centimeters away from the end stop. This track does have a very nice measuring system built into it, so we don't need to use the meter stick in this case. Instead, the measuring lines on the track will be sufficient. Now, precision is pretty important here, so we are going to measure this distance to the nearest 1/10 of a centimeter. This will be the displacement x necessary in our computations, and its value will be reported in Table 1 of this lab write-up. We will use a stopwatch to measure the time that the cart takes to travel this displacement. And to record an accurate measurement here, we need to start the watch immediately upon releasing the cart and stop it as soon as the plunger reaches the end stop. To help with this, to ensure the accuracy, we're going to have the same person who releases the cart do the timing. In this case, it'll be me, but if we were in person, or if we recreate this lab when we do see each other, one member of the group will do both the timing and releasing of the cart. We'll do this 5 times in total, so a total of the first trial plus 4 more in order to record these values and calculate an average result for those 5 trials. After that group of 5 is complete, we're going to change the displacement by reducing the distance by 5 centimeters. And then we're going to repeat the same activity as in step number 6 5 more times and report that information onto our table as well. We will do this a total of 5 times, so there are 25 measurements taken at 5 different displacements. And then we will repeat the entire process again by adding another wooden block onto the or underneath the cart track. And we'll repeat the whole process over again so that we can have a full amount of data recorded in table number 2. Once we finish building table number 2, that will signal the end of the data collection, and that's the longest or most time-consuming portion of this lab. Once we have the data collected, we will need to analyze the data, perform the mathematical analysis against that, along with the formulas that are being referenced from our textbook. We should be able to calculate this information, and you'll be able to add your interpretation to the remaining questions at the end of the lab. Normally at this point I would open the floor to discussion in case anybody had any questions on how the experiment should be operated, but obviously we can't do so in this pre-recorded setting. So with that in mind, I'm going to stop this portion of the video and we'll pick up with the experiment after I've already got it set up. Thanks for watching.